We move on to transformations of trigonometric functions. But before that, we need to know exactly how the graphs look like. Now, we did this again, IGCSE, and this is just a revision of it. This is the sine graph, where it starts from 0, and the period, meaning one revolution, meaning one cycle, is 360 degrees, right? So, this is the sine x graph. The period is 360 degrees, or you can call it 2 pi as well. And then we also know that the range, it goes from 1 to -1. So that means f of x, which is the range, is between 1 and -1. Okay? And we can add this other information that is there, which is a center line, which is at y equals 0. F of x equals 0 is the center. But I mean, this is constant for all of these, so I mean, it's just, yeah. The next graph is the cos graph. And again, the period is the same, 360 degrees or 2 pi. And the range is between -1 and 1. And again, f of x equals 0 is the center. The only difference between the sine and the cos is that the cos starts from 1 when the degrees are 0, while the sine starts from 0 where the degrees are 0. However, they are the exact same curves, right? They are just the starting point is different. The tan graph, as you can see, looks different as well. So tan x, the period in this is not 360 degrees, it is 180 degrees instead, or you can call it pi. Yeah, as you can see from here, 90 up to 270, which is 180 degrees. Okay. The range goes from infinity to -infinity, x to infinity, and again the center line is 0. What we know else about the tan graph is that it has asymptotes, and the asymptotes are at 90 degrees to 70 degrees and any plus minus 180 from there, right? And those are where the asymptotes are at. So these are the graphs that you should know. Just a revision from IGCSE. Now we'll move on to the new content. So first one, transformations. Again, graph of y equals to a plus sine x. This is sort of following from the functions topic of transformations, where translations like this are vertical translations because you are adding that a constant to the entire function. That means you are shifting it either upwards or downwards, the entire sine graph. And so we see that y equals to a plus sine x is just y equals to sine x. Y equals to sine x, that is translated a units up or down, whatever the sign on a is, right? And we can see from this example, this is the example when a is 1. And as you see that the graph has been translated upwards. Every point is now plus 1 of its original. And the changes are made to the range. For this is between 2 and 0. And the center has now been shifted upwards as well by 1, which is at 1. Okay? And the period remains the same. Okay? So it has just been translated a units. In this example, specific example, 1 unit upwards. Next, we look at the graph of y equals to sine x plus a, where the plus a is within the bracket. Meaning, what has happened here is that sine x has gone to sine x plus a. That means that x has been transformed to x plus a. And this, if you remember from the functions topic, this means there is a translation horizontally by negative a units. Therefore, if you have y equals to sine x plus 90, then we're gonna translate it to the left by 90 degrees, right? So if this was the original curve, what's happening is every point is now going to the left by 90 degrees. Every point is now going to the left by 90 degrees, and so on. Okay? And that gives you the new transformed curve. Next, on the same grid, sketch the graphs of y equals to sine x and y equals to sine x minus 90 for 0 up to 360. So we should know what sine x looks like. Okay, sine x is just a normal start from 0. Period is 90, range is from 1 to -1. So 1 up to -1. This is 360 degrees. This middle part is 180 degrees, this is 90, and this is 270. This is obviously 0. Then what we're doing is we are shifting it to the right by 90 degrees, because x minus a means moving to the right by a. So we're moving to the right by 90 degrees. This is all from the functions topic, right? So we're moving each point to the right by 90 degrees. That means if this is 0 right here, we're going to move that 0 90 degrees to the right here. Then this is at 1, moving 90 degrees to the right here. And every point is basically moving to the right by 90 degrees. And so we have a curve like this. And obviously we will continue this here, because from the back part of this, we get that this point is at negative 90 degrees. So if we move it 90 degrees to the right, this point right here is going to come at right there. Therefore, the blue curve is the y equals to sine x, the original, while the red curve is the y equals to sine x minus 90 degrees. Next, sketch the graph of the trigonometric function y equals to 2 cos x plus 90 plus 1. Now, this is a combination of transformations. And if you have gone through the functions lesson, where I looked at the combination of transformations, this should be quite simple for you. So, firstly, we can draw out our cos graph. And remember, our cos graph is like this originally. Yeah, where this is 360, this is 270, this is 90, and this is 180 degrees. And obviously this is 0. Then what's happening here? Look at it step by step. So there is this right here, which is the translation in the x direction, where we are moving it to the left by 90 degrees because it's plus 90, right? Obviously the translation is negative a is 0. So negative 90, 0. That means you're moving to the left by 90 degrees. Then what happens next is we multiply by 2 first, then we add 1, right? Because if you would have added 1 first, it would have become cos x plus 90 plus 1, then multiplied by 2. And this is different from this right here. So we first multiplied by 2, then we add 1, right? So we're going to go step by step. We're going to translate it to the left by 90 first. It means every point goes to the left. This goes here, this goes here, this goes here, and this goes here. So we have something like this, right? And that's the first step, meaning the x translation has been done. Then we want to multiply it by 2. And when we multiply by 2, we are stretching it in the y direction because we're multiplying the y by 2 and not the x. And so every value of y just doubles in size, right? So if it is at negative 1, obviously this is a negative 1, and this is positive 1. If it's at negative 1, it will go to negative 2. If it's at 0, it remains at 0. If it's at 1, it goes to 2. Right? And so the new curve we would get is something like this, where we are just making it larger. Right? And so the difference between the red and the green is that the green is 2 times what the red is. That's scale factor 2 in the y direction. Then we want to add 1 to it. That means we want to translate it upwards by 1 unit. And what that does is everything gets added by 1. Therefore, this green will come here. This one will come here. This thing right here will come here. And then goes up here and goes up here. Then we get something like this. And so the only difference between the green and the purple graph is that it has been translated 1 unit to the top. And look at what has stayed the same. The period is still 360 degrees. The range now is f of x going from 3 to negative 1. The center f of x is at 1. And from this we can also find that the amplitude, which is the height to the center, is 2. And look at what has made the changes for each of these. The period remains the same because there is no horizontal stretch. There's only a translation, which doesn't really change the period, because period is how many revolutions you get, and that is just how stretched out your curve is. Your amplitude was changed because of this scale factor right here. It multiplied it by 2. That means the amplitude that was at 1 now became 2. So this one was done because of the scale factor in the y direction change. Then the center was changed due to the translation that we had at the end. The next part, example 3, f of x is 3 cos 2x, and the domain is between 0 and 360 degrees. And we want to write the period and the amplitude of f. Now, let's see what exactly happens with this transformation right here. So firstly, x has turned into 2x, and y has turned into 3y. This we get from the fact that it's now cos of 2x, and this we get from the fact that it is 3 cos of 2x. So this is the main thing that gives you y, makes it 3y, because you're multiplying by the whole thing. And this 2 gives you that x is going into 2x. Now, this one right here, what it does is it stretches by scale factor a half. If you don't know how I got this, go back and watch the functions video. I explained this throughout, yeah? And here, this is the stretch in the y direction, scale factor of 3. This is obviously in the x direction. So what this does is, if this was 360 degrees for one revolution, what this has done is it has stretched it by a half, meaning it has made it thinner, compact, and so it looks something like this now. And therefore one revolution is now 180 degrees. Therefore the period right here has changed, and it has now become 180 degrees instead of the original 360 degrees that is for cos x. Then the amplitude, what has happened here is, because of this stretch in the y direction, remember, any change in the y causes a change in the amplitude. A change in the x would not really cause a change in the amplitude, because amplitude is the vertical height. Same goes for period. Any change in the y will not cause a change in the amplitude, because amplitude is an x-axis change, while the transformation will be happening in the y-axis. So they are completely independent of each other. So the period right here, originally it's 1, and now whatever is 1 has been multiplied by 3 to get 3. Whatever is negative 1 has been multiplied by 3 to get negative 3. Therefore the amplitude now, what has it become? From 1, the amplitude has become 3, meaning the height between the center and the highest point. So the period is 180 degrees, while the amplitude is 3. Then the coordinates of the maximum and the minimum points on the curve y goes to f of x. Remember, the maximum and minimum points for the cos graph is firstly at 0, 1, yeah, and then it's at 180 and negative 1, then it's at 360 and 1 again. Obviously these two are maximum, and this is a minimum right here. Now because of this, what has happened is it has been stretched by scale factor half, which means when our degrees are 0, now the degrees are going to be 0 times a half, which is still 0. When the degrees are 360, it's going to be 360 times a half, which is now 180. So this one changes to 181, yeah? And obviously 180 negative 1 changes to 90 negative 1. Yes, and this is just, I'm talking about the x changes. Obviously the y changes as well, because the amplitude has now become 3. That means the max is going to be 3 here and negative 3 here. Now obviously we have a second revolution as well. So we started off with this up to 180. We also have a second revolution up to 360. And so we would get our other minimum points as well. Remember, this is the 90 and negative 3. This is the 180 and positive 3. Then we have 360 and positive 3 as well. And we have 270 and negative 3 as well. And obviously the original 0 and positive 3. So these are your maximums: 0, 3, 183 and 363. And your minimums are now 270 negative 3, and 90 negative 3. Then we go on to C, where you want to sketch the graph of y equals to f of x, which is this one right here. And I've already drawn the cos graph, which you should know by heart, right? So this is a cos x graph. And we want to apply these two transformations to it. So firstly, we know that it stretches by a half, meaning whatever is at 90 will become at 45, whatever is at 180 will become at 90, whatever is at 360 will go to 80, and so on, right? So your curve starts at, it goes somehow like this. And this is just due to the stretch in the x direction, which is based on the 2x. So the period becomes 180 degrees from that. Then we want to stretch it in the y direction by a scale factor of 3. That means wherever it's at 1, we make it to go to 3. And wherever it's at negative 1, we make it go to negative 3. And so we're going to draw this exact thing, just that the points have now been enlarged. So these are going to be the points on the curve. Obviously, the points at 0 remain at 0 because 0 times 3 is just 0. So we end up getting something like this. And this is going to be your graph of y equals to f of x, which is 3 cos 2x. Then use your answer to part C, so this sketch right here that we have, the purple sketch, to sketch this graph right here, which is 1 plus that. And 1 plus that meaning just you translate it upwards by 1 unit. That means wherever it's at 3, it will now go to 4. Wherever it's at 0, will now go to 1. Wherever it's at negative 3, will now go to negative 2. And so the new curve, let's just color it green. It's going to look like, starts at positive 4. And then the center is at 1. And the minimum is at negative 2. So it's just basically the purple graph, just translated slightly upwards. And so that's how the graph of 1 plus 3 cos 2x would look like. So we just take the purple graph, and every point we translate it 1 unit upwards. And then this is on the same grid, sketch the graphs of y equals to sine 2x and y equals 1 plus 3 cos 2x for 0 up to 360 degrees. The graph of 1 plus 3 cos 2x we have already done. So let's just draw that right now on the curve. So this right here is the graph of 1 plus 3 cos 2x. This is from the previous question. Then they tell us to also draw the graph of y equals to sine 2x. This is the normal graph of y equals to sine of 2x. Where is the normal sine graph? Which is compressed, yeah? Scale factor of a half. Stretched by a scale factor of a half. And then we are told to state the number of solutions. Now remember, the number of solutions to that equation where these two are equated to each other. Remember, you're looking at when the y of this is equal to the y of this, considering the x's are the same. And so this just tells you how many times they have a simultaneous solution, right? And graphically, if you remember from IGCSE, it is the number of times that the graphs meet. So let's count that. It meets here once, twice, thrice, 4 times, right? And so there are going to be 4 solutions to this right here.